Okay, we've got a couple other inverse Laplace transforms to think about. So here's three more. So e to the at is going to equal the inverse Laplace transform of 1 divided by s minus a, and sine of kt is going to be the inverse Laplace transform of k divided by s squared plus k squared, and cosine of kt is going to be L inverse of s divided by s squared plus k squared. Okay. So let's start with the combination of the e's and the polynomials. So let's say we were doing L inverse of 1 divided by s squared minus 1 divided by s and plus 1 divided by s minus 2. Okay? So that would equal L inverse of 1 divided by s squared minus L inverse of 1 divided by s and plus L inverse of 1 divided by s minus 2. Okay, so now the first two are the polynomials that we did in the first video. So when we see s squared, 1 divided by s squared, remember, it's s to the n plus 1. So what is n in this case? N is 1. And so that's just going to be t. And then 1 over s, you can think of that to the 1 power. What is n? N is really 0, so t to the 0 is really just 1. Okay, then we have 1 divided by s minus 2. Now this is going to correspond with this one that we have at the top right here. This 1 divided by s minus a is going to equal e to the at. And so 1 divided by s minus 2 would be plus, now, e to the 2t. Okay? Now this one, it's kind of obvious. That's a 1 divided by s minus a. So let's look at one that is not as obvious. Okay. So let's say we were trying to do L inverse of 1 divided by 4s plus 1. Okay, well, the formula for the inverse involving exponentials is s minus a. Okay? So, first of all, I do not want that 4 on that on the s. Okay, so I'm going to have to pull that out of the whole thing just to begin the problem. So that's going to be 1 divided by 4 times L inverse of 1 divided by, well, s plus 1 divided by 4. Okay. But the formula also said it's 1 divided by s minus a, and I've got s plus a at this point. So I need to think about this problem again. Can I turn this into subtraction? Well, yes, I can turn this into subtraction. This would be 1 divided by 4 times L inverse, these are equal, of 1 divided by s, now minus negative 1 divided by 4. Okay, so the minus and the negative will turn that thing into positive. So at this point, I can use the formula because I have a 1 divided by s minus a. The a is negative, but that doesn't matter. So this becomes 1 divided by 4, now e to the minus t divided by 4. Okay. All right, let's try another one. Let's try one involving sine. Okay? So if we, all right, so if I'm doing this problem, so if it's just s minus a, then it's going to be e. But if you have L inverse of, let's say, something of 5 divided by, let's say, s squared plus 49. Okay. So there's a question that, how do I know, all right, if there's an s squared, I'm going to think it's going to be associated with sine or cosine. Okay. So the question then becomes, okay, I see an s squared, so I'm thinking it's involved with sine or cosine. Which is it? Well, if we look at our formula, So if there is an s on top of the problem, then it's going to be associated with cosine, okay? If there's just a number on top of the problem, which is that k, that is going to be this k that is going to be multiplied into the sine of kt, that tells you that if there's just a number, it's going to be associated with sine. If there's an s, it's going to be associated with cosine, okay? So on this problem right here, we do not have an s on top of this problem. And due to the fact that we do not have an s on top of this problem, you need to automatically think, well, this thing is going to be associated with sine. And so now you have to think about, well, what goes right there? What do I need to actually put right there? Well, it's k divided by s squared plus k squared. So you'll take this number right here, 49. This is really k squared, okay? That means the k is going to be 7. So you need to get a 7 right there. So this is equivalent to writing, okay, so 5 divided by 7 times L inverse of 7 divided by s squared plus 49. Okay. Okay, so we have a k divided by s squared plus k squared. So that tells me that, yeah, I can use the formula. So that would equal 5 divided by 7 times sine of 17. So that's the inverse transform of that. Okay, so let's say we're trying this one. L inverse of 2s minus 6 divided by s squared plus 9. Okay, well, the first thing I would do on this problem is I break it into its pieces. Okay, so we can go ahead and say, well, this is the same thing. You know, let's pull the constants out as well. Say 2L inverse of s divided by s squared plus 9 minus 6 times L inverse of 1 divided by s squared plus 9. Okay. Now, on that problem right there, this one, you don't need anything extra because it's s divided by s squared plus k squared. But that problem right there, that's going to be a k divided by s squared plus k squared. Now, k squared is 9, so that means my k is going to be 3. And so this is going to equal now 2 times L inverse of s divided by s squared plus 9 minus 6 divided by 3 times L inverse of 3 divided by s squared plus 9. That. Okay? And 6 divided by 3 is just 2. So I could have just pulled out a 3 and left it. Pulled out a 2 and left a 3 in there. So that's going to equal now 2 cosine of 3t minus 2 now sine of 3t.